think this is a really important question, and this is what we are hoping for, that someday we can control the immune system to not only kill cancer cells, but also stop autoimmune disease as well too. It's going to take a little bit of work. The field of immunology, of modern immunology, is really less than 100 years old. And we have many things that we need to learn, but just seeing the advances that have been made in the last 25 years in terms of how the immune system can see cancer and destroy cancer, and how we can facilitate that by putting in drugs that essentially take the brakes off the immune system, is a really exciting step forward. We're not there yet. There's still many people who don't benefit from these drugs, but we've made big advances, and every year there's more advances to be made. So I see in the future that the immune system will be trained to do many things to prevent human disease. Yeah, so the future of cancer treatment has gone through many different changes. Before the immune system got involved, there were considered to be 6 pillars of cancer therapy. So these would be radiation, surgery, targeted drugs, some other things as well too. And while they were effective, they were not inducing what we would say durable responses. That means someone would actually be cured of their cancers in most cases. And so now comes along the immune system, and now we're seeing patients who are being treated in addition to the standard of care treatment, are being treated with these immune activators. And now we're finding people who get 1, 2, or 3 treatments and are still alive 20 years later with no evidence of cancer being there. So these are the lucky ones. These are the ones who respond well to the therapy. But it's only in general about 20% of the people who are treated with these drugs are giving these kinds of effects. So our hope is we have to understand why, what was it about those 20% of the people that led them to respond so well? And what can we do now for the other 80% that we can get them to respond in a similar way? So this is where much of the research, including mine, is focused. We think that one of the things that will improve cancer therapy, immunotherapy, is to personalize it. And we have found a way of identifying the mutations in tumors, and all tumors have mutations, that are unique to that tumor and completely and different from the normal cell. And we've been able to make in experimental animals vaccines that incorporate these mutations that we can predict are going to be good targets for the immune system. And then you vaccinate just like you would vaccinate against polio, say, for example, or SARS-CoV-2, the COVID-19. And you induce a T cell response that then goes and sees specifically those tumor cells. We've done it in mice. There have been people in my institution and in other institutions around the world that are doing it in humans, including this creative group from Germany, the BioNTech group that developed the COVID-19 vaccine, are going back to their original formulation where they were actually trying to do the same thing for cancer as well too. We think that if we can do this, we'll make cancer therapy more effective, more specific, and safer than the immunotherapies that we have today. Well, I mean, I've had a few of those. I would say probably the most important one for my modern career was the aha moment, as people say, was that we were looking at a molecule that is made by immune cells, gamma interferon. My colleague Antonio Salata was with me early on at the time that we learned about gamma interferon and what it did and how it worked. And so we began to ask questions about, could we modify the response to gamma interferon and see what happens to different challenges? So of course we use viruses and bacteria, which everybody in the world was using. And then we decided to use it against cancer. And the idea was we had a tumor line that we placed into experimental animals. Some of those animals were unable to respond to gamma interferon, and other animals responded normally to gamma interferon. And what we found was that we put the tumor in, and the animals that responded to gamma interferon rejected their tumor and remained alive and were tumor-free. The animals that couldn't respond to gamma interferon didn't handle the tumor well and actually ended up dying of their tumors. And so this was an aha moment, because most of the world at that point in time never considered that the immune system could actually handle the tumor, but that was wrong. And that was probably my biggest aha moment. And then for the next 10 years, we kept doing experiments to really show that it was more than gamma interferon. It was the immune system itself, and specifically T cells in the immune system, that were doing the killing. This is the art of science, I think. When you are faced with a lot of criticism, that people say, you're doing it, I don't know why you're doing it. We've all know that the immune system doesn't see cancers. And yet every time we did another experiment, the experiment said the immune system was important in treating cancer and dealing with cancer. And so we followed our data. And I think that's an important lesson, to know when your data is correct and taking you down a road that nobody has traveled for a long time, and when your data is wrong and telling you you should be doing something else. And so I guess it takes a little bit of luck too, and our luck was that we followed the right road. Well, I can tell you one thing. I drive a car that has a license plate that is UZD4S. And if you look at that, people take time to figure out what that means. And what it means is use the force. And so that was from the first Star Wars movie. And that's how I see what we really have to do to cure cancer, is use the force.